The lesson today is on what are called complex fractions, and this also is in the Big Ideas book in Lesson 7.4 in the Big Ideas book. It's just the second part of it. I figured that adding and subtracting was hard enough on its own, so now we've got another concept within that though. First of all, again, you did the Delta math the other day and they had some problems like these. So are these two the same thing? This one has 3/4 on top of 5. This one has 3 on top of 4/5. But they're both 3, 4, 5. Are those the same thing? Well, no, they're not. How do we know? Well, we probably talked about in class that day with the Delta math that when you divide, this is like dividing by 5. And when you divide fractions, what you actually end up doing is multiplying by the denominator. And so we're going to multiply this by 1/5. And that comes out with 3/20. Okay, well, how about the other one? Well, the other one, once again, we're going to figure if this is a division problem, then that means we need to rewrite it as a multiplication problem. And that comes out to be 15/4. So no, they are not the same thing. And my point there is just to make sure you understand what's in the denominator, what's in the numerator, and how do some of those things work. So when we get into some examples that have variables in them, we just have to know what we're doing. So once again, we could rewrite this as x/2 divided by x squared. Well, that's the same thing as x/2 times 1/x squared. And so as we multiply straight across, we're going to get x/2x squared. And again, those x's can simplify down, and the answer then in simplified form is 1/2x. Let's look at the next one. We have x/3 divided by 5/x. What we need to do is flip that bottom one so that it's x/5 in a multiplication problem. And here our answer just comes out to be x²/15. These next two start to get more complicated, and this is what we're into with this section is complex fractions. So over in the margin, notice you have to add or subtract before you can simplify the numerator and denominator. In other words, we can't just flip this bottom and multiply it times that, because there's too much going on. This adding and subtracting is not going to work that way, so we can't do that. Secondly, if you look at the first example I have, compare it to, example C, compare it to example D, you might notice they are the exact same problem. And the reason I did that is I want to show you two different ways to go about solving simplifying these fractions. The two ways are actually listed out down here. I'm going to just go through it. Since they're just numbers, there's no variables, I'm going to go through how you might do this. So because we have to add or subtract before we can simplify, then we have to have common denominators. So I'm looking at the 3 and the 5, and I'm thinking, okay, I need to multiply this by 5, and this by 5, and this by 3, and this by 3. So my numerator becomes 10 plus 12/15. And then my denominator, I need a 5 here, and I need a 2 here and here. So that becomes 5 minus 6 all over 10. Okay, so now I'm going to take a second to simplify that further. I have 22/15 all over -1/10. Okay, now it's in a form that I can deal with. Now it's like the ones I was doing a second ago. So now I can take this times 10/-1, and I can simplify that. Well, I know 5 can go into both of those, so I will divide out a 5 out of each of those, and I am left with 44/-3. All right, these are called complex fractions. They're getting a little complex, aren't they? Let's take a look at example D. And again, it's the same exact problem, but I want to show you a different way because I don't know as we were working through that problem, if you had this thought, it seemed a little tedious. Like we had to go and multiply, 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 multiply. There's a lot of little tiny multiplying going on. And so the other way to go about the problem is instead of all that little tiny multiplying, we can do just a fewer big multiplying. And that is this second option. Multiply the top and bottom of the, that's supposed to say by the LCD of the entire problem. So if we look at 3, 5, 5, and 2, what is the lowest common denominator with those? Well, it's going to be 3, 5, and 2, and 3, 5, and 2 is 30. So what I want to do is I want to multiply this side by 30 over 1, and I want to multiply the bottom by 30 over 1. And again, back to Mrs. Weigel's rule, this is a 1 in disguise. 30 over 1 over 30 over 1. You're really just multiplying by 1, so you're staying within all the math rules that are valid rules. Okay, my next step, I'm going to go ahead and show my work, show a step here that when you finally get used to it, you can probably skip this step, but I'm going to go ahead and show it here. So I need to distribute and multiply this times both of the numerators. So the way I do that is I get 60 over 3, and then I multiply by that second fraction, and I get 120 over 5. I'm going to do the same thing in my denominator, so I get 30 over 2 minus 90 over 5. Okay, that little step, like I'm saying, I'm showing that so you can see what I'm doing here, but the good news, all of these fractions go away because 60 over 3 reduces down to 20, 120 over 5 reduces down to 24. In my denominator, I have 30 over 2, that's 15, and 90 over 5, that is 18. And so when I just do my simple math now, I just add those together, and I get 44 over negative 3. And you can see that is the same exact answer I got a second ago. And so those are just two different methods to solve this kind of complex fraction. Okay, well that was with just plain old numbers. Now we have to get into what will we do if we have variables. So again, these are the two steps, or the two options, and either way works. It does not matter which one you use, either way works. Now, I say that, and you might say, well, which one should I use though? Well, here's the deal. I think that option 1, that is to do all the little multiply, 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 that is easier when you have fewer fractions. Like look at example C. There's not a whole lot, like that 3 is just a big 3 and the 1 is just a big 1. So there's not a whole lot going on. So that might be an easier option for option number 1. Whereas if you look at example A, we have 4 little tiny fractions. And since there are so many little tiny fractions, option 2 might be better. I'm going to do example A using option 2. And that is, I want to look at my common denominator for all 4 of my little tiny fractions. I have a 2, an x, a 5, and an x squared. So my common denominator is 2, 5, x squared. That's 10x squared. So I'm going to multiply everything by 10x squared over 1. So I'm going to distribute 10x squared times 4 over x is 40x squared over x. I distribute it to the next one. I'm going to get 30x squared over 2. Now, in my denominator, I'm going to do the same thing. I'm going to take that and distribute it. So I get 20x squared over 5 minus 60x squared over x squared. And so this is where I said that middle step here, maybe some of you can skip that step along the way because each of those simplifies down and we get rid of all the fractions. There are no more fractions here because 40x squared over x is really just 40x and 30x squared over 2 is really just 15x squared. In my denominator, the first part reduces down to 4x squared. The second one reduces down to a 60. Okay, so now if I could factor these, I could factor them. The only reason to factor them would be if they simplified down. But sometimes you don't know if they're going to simplify down or not. So maybe it's a good practice to go ahead and factor it down. Because I can see that a 5x can come out of this one. And in my denominator, it looks like I can factor out a 4. Now, if there was anything else to factor down, I could do that. But as I've done so far, nothing is going to cancel. And so I'm done with example A. I mentioned that there are the two different methods, and each method maybe has a better time or not as good of a time to do it. So again, I might save some of these for a warm-up tomorrow in class. I think I want to go ahead and do example C using the top method, the example number 1, the method number 1, and that's finding the least common denominator of each and then dividing. So in other words, my numerator is already a number. I don't need to change my numerator at all. My denominator, though, I do need to combine that. I cannot just flip that over and multiply it because that subtraction doesn't let me do that. So I need a common denominator. It's kind of tricky because that's a 1, but this is a 2y. So we need a 2y in the denominator. So 2y over 2y is the same as 1. And then if I go ahead and combine here, I'm going to get 3 over 2y minus 1 all over 2y. I cannot simplify those two y's. There's not a factor. You can't factor them out. But what I do need to do is I do need to flip it and multiply it by the top one. So I need to multiply this by 2y over 2y minus 1. And so my final answer is going to be 6y over 2y minus 1. Okay, again, that may or may not be enough examples for us, but I think that's all we will cover in today's video. If we need to do more examples, we can do these B and D as a warm-up in class. Now, I would say go ahead and fill some stuff in on the summary. You might fill some stuff in right now on the summary, and maybe if you don't have enough to fill in now, maybe when we get to class tomorrow, someone in your group can have some ideas of what you could write down in the summary.